So, reward models. In this video, I'm going to be talking about reward models that can help your LLM to align perfectly with the human values and preferences. We are diving into a different world today because we are going to talk about not just LLMs in general, but how we can make the LLMs better and respond well, just like a human. Think of this like a chatbot. You have a chatbot which responds to user questions, and you are really feeling good about the chatbot. But there is something which is quite missing in that chatbot, and you want to make it a better sounding, a better chatbot, which is more closer to and it responds. You want it to respond more closer, just like a human. So the process to do it is fine-tuning, of course. But how do you fine-tune? On what data do we fine-tune? So this is where this reward models comes into picture. So this reward model, you are not going to use the reward model as an LLM that will give you a response. It's not like an instruct model, which you can ask questions and it gives you a response. The reward models will output a number. Let's say from 0 to 100, a scale between a scale of 0 to 100, it will give you a number, and that number will represent the effectiveness of your responses from your own LLM. So let's say you have an LLM A which responds to your queries, and you take those let's say thousands of queries and you get thousands of responses, and using those responses, let's say a particular pair of response and of user question and response, you feed it to the reward model, and that reward model gives you a score saying how accurate the response is to the user's question. Now once you have that set of question answer pairs or any long conversations, but effectively the user and assistant answering that, you take those and feed it to a reward model. It gives you the scores. So you have thousands of scores, and based on that score, based on that data, you can again feed it to the fine-tuning pipeline, which will again fine-tune your models to align more closely to what we want. So the fine-tuning process will effectively improve your model and make it more closer to the higher values, which is a positive response, and deter from the negative values responses. Okay, so coming back to the starting problem. Now, have you ever felt like AI is almost there, but it's not quite yet? Like it can write a poem, but it doesn't really get the point of poetry. That's exactly the gap that the reward models are trying to bridge. It's not just about teaching AI to write grammatically correct sentences, because even if the sentence is grammatically correct, it could mean differently until and unless you speak it out. It could mean different. For example, there is this famous exercise that when you emphasize different words in a sentence, for example, I didn't say that he stole the necklace, you can stress different words in a sentence, and you can get completely different meanings and interpretations from that sentence. For example, I didn't say that he stole the necklace. I didn't say, but someone else did. That's focusing on the subject or I of the sentence. When you say, for example, I didn't say that he stole the necklace, then I could mean that I didn't say he stole the necklace, but someone else did. So you can see that when you place focus on different words, it could mean different, which means that the output that you get from the LLM has to be perfect in that it shouldn't leave any ambiguity when you're reading that out. And if you're decided to convert to a speech output, then it's even more important of how that is pronounced. But let's talk about the text output only for now. Now, this video, I'm going to introduce you to a new model from NVIDIA. not a new model, but it's basically trained on Llama 3.1 Nemotron 70 billion reward model. Now this model has been, it's the number one model in the benchmark, the reward bench leaderboard, and this leaderboard has been prepared based on this paper. Now it stands on number one, which means that you can use this model to train your own models. And if you want to learn more about the fine-tuning exercises, you can have a watch of this video and this video where I go through the complete steps of how to fine-tune your own models. And in this video I go ahead and explain the different steps of preparing your own database or preparing your own data sets. Now the dataset that you require here is simple. You need the outputs of the Nemotron and you need the inputs to this reward model. Now let's break down the stats. You can see that we have 94.1 overall accuracy of reward bench, 95.1 scores for safety, and 98.1% in reasoning. Now these aren't just random numbers. We're talking about AI that's making the right call almost every single time. Okay, so it's not just following instructions, it's understanding complex logic and making decisions that are safe and sound and align perfectly to the human values. Now they used two approaches to do this, to make this model. The first is the regression style model. You can have a look at this paper. And the other is the Bradley-Terry reward model. So that's a reward model. You can have a look at this paper. Now, talking about the real world applications, where do I see these could be used? First, as I've already mentioned, it's the supercharged chatbots. Let's imagine customer services bots that don't just respond to requests, but do with empathy and understanding and closer to human values and preferences. You can use this to do the financial analysis. So you can use AI that can crunch numbers, spot trends, and generate insights that even seasoned analysts might fail. You can use a third example could be personalized education. Picture AI tutors that adapt to each student's learning style, providing tailored guidance and support. You could ask basic questions to the student, and the personalized educators will understand where the child stands. Is a child which has a high IQ or a low IQ, and based on that we can structure the courses instead of the typical college where the professor feels that everyone is an IQ of 160 and above. You can use healthcare diagnosis, AI systems that can analyze extremely complex medical data, assisting doctors in making more accurate diagnosis. So whatever may be the use case, we need to fine-tune the models, and this model gives you a way to generate fine-tuned data and ultimately to fine-tune the model. So let's look at the model here, and you can see that we have this model. This model can be used in the NIMS service, so build.nvidia.com. We can use this model. We can use this model here, which is Llama 3.1 Nemotron 70 billion reward model. And what this gives is, let's say we have this user and assistant input-output pairs, and the user asks, I'm going to Paris, what should I see? And this Paris, the city of light, there are so many amazing things that you can see without giving any reference to the kinds of things that you're going to see. But this model gives an output of 19 as a score for this response. Now let's change this output to, let's say, Paris, the city of love. You can see so many things like Eiffel Tower, Notre Dame, and the beautiful Seine River. Let's run this, and you can see the output is 25. Okay, so based on the outputs or based on the conversation that your assistant give, you can use another user and assistant, but ultimately this will give you a score. And if you have such thousands of conversations, you can have thousands of scores, and using this as a single data, you can fetch this in a JSON file, and you can convert it into a dataset. So you can use that JSON file as a dataset for your fine-tuning exercise, and you can fine-tune your model so that it responds better. Okay, so you can try it in Python as well. You can automate the script, put in different questions and get in the response, prepare the fine-tuned model. And you can see this is the dataset that has been used to make this sort of a model. So this is the dataset. As you can see, we have this prompt C#. So the response is that C# is a high level, basically a definition of that. So among the helpfulness, we can see that about the dataset itself consists of 41.5%, has a score of 4 here. So this is helpfulness score. Correctness 47.7% has a correctness of 4. Coherence 71.6% of 4. I'm just trying to understand the dataset, but this is the dataset that has been used to fine-tune that model, which is this Llama 3.1 Nemotron. And you can see the model card here. You can have a read of the model card with the different parameters and different methods that has been used to fine-tune this model. This is the benchmark. We can see that we have Nemotron on the top, and this is the best reward model. Again, it's very important to remember that this is just a reward model. It's not the actual LLM. The reward model will give you the will judge if your model is responding correctly, and it's whether it's more closer to the RLHF feedback that we have done. Now for the testing out this in NVIDIA, you can go and go to Hugging Face and go to this model, but it has a refined version as well, which will work in Hugging Face, and you can download this model. You can see the files and versions here. You can go and download this very big model, but it's normal. My PC will not work, but we need to use some runbots like service to use virtual GPUs, to use the cloud GPU. But you can see this, how this model has been trained. The base model is this, the fine-tuned version is this instruct model, and again we fine-tune to make this model, and there are quantized model as well. So this is the new model, which will make the models more aligned to the human preference, although sometimes we don't want such kind of human preferences when we are trying to for example, discover new things. We're trying to get a new view of a viewpoint for any topic. But generally for different chatbots and different customer services and different complying with the government regulations, we would need that it's more aligned to the human preferences. Don't say bad stuff, not safe for work stuff, or generating violent or criminal text that should be avoided at any cost. But yeah, I hope you got something from this video. Now if you want to fine-tune your models, you can watch this video of how we can use Unsloth library to fine-tune. If you want to create your own dataset for that fine-tuning process, you can watch the next video which will show you the way to create data for the fine-tuning exercises that you want to do for your models. Also, I would like to thank my Patreons for supporting me, and please join my Patreon. That would be great if you could support me for this poor YouTuber. But yeah, I'll see you in the next one.